So we get to what might be the simplest section in the notes from here on out, as we ask this question of adding and subtracting polynomials. And the only notes I have to give you on adding and subtracting polynomials is combine like terms. That's all we're doing. And the one thing I will suggest as a hint is watch parentheses and negatives and or subtraction signs. But that's it. So these are written in a way that they represent polynomials, as in a trinomial plus a trinomial. But with those parentheses, we ask that same question we always ask. Are they important? Well, we look inside and there's nothing going on, right? Nothing, no like terms to combine. We look outside them and there's nothing to distribute. So they really are doing nothing in the problem. Like I said, they're really just there to make it look like a trinomial plus a trinomial. So I'm going to write the problem without them there. Then look at the next set and notice the same thing. No like terms inside, and just a plus sign outside means even those are completely unimportant. So we can drop them, and we're looking at a string of terms where we're going to combine like terms. Now again, looking at like terms, the x squareds are like terms, but you combine them and you get an x squared term. That's how like terms work, right? Do not add the 2 and the 2 and get x to the 4th. This is 3x squared plus 5x squared. 3 plus 5 gives you 8x squared, right? When you're combining like terms, keep that like term in your result that you get. Just like anything, just like here, negative 2x plus 6x, the x's make them like terms. Negative 2 plus 6 is a 4, so 4x. And the constants of 4 minus 9 giving me minus 5, which gives us those 3 terms. And notice again, there are no like terms there, so that's it. Final answer. Okay, so we get to this one where we're not necessarily adding or subtracting, but we're just making sure we understand the role of this negative sign out front. Negative out front of parentheses, we've said many times, is like a negative 1, which means you want to distribute the negative, which really just does nothing but change the signs. But it does make those parentheses important, right? That's always the question you ask. So a negative 1 times a 3 would be a negative 3, so negative 3x squared. And a negative 1 times a negative 2 would be a plus 2. So that's it. Clears our parentheses, no like terms, done. And so the reason that's important or helpful is we get to a subtraction problem where, similar to above, we go through this first set and say those parentheses aren't important. They're not doing anything. But the second set with a minus sign out front are very important. That minus sign, that subtraction sign, is like a negative 1, and it's going to need to get distributed to every term in those parentheses, making that a minus 5x squared, a minus 6x, and a plus 9. Very important. That's a very common mistake to miss that distribution of the minus or the negative 1. But from there, just combining like terms, 3x squared minus 5x squared, 3 minus 5 is a negative 2, so negative 2x squared. Negative 2x minus 6x would give us a negative 8x, and 4 and 9 give us a 13. All like terms combined, final answer.